Good evening to all. Today we are starting a new chapter. The chapter name is Light, Reflection and Refraction, and it is the first chapter in physics for class 10 CBSE students. We have already covered few chapters in our YouTube channel. We started with chemical reactions and equations, which was the first chemistry chapter. Then we did our environment, which is a normal common chapter. And then we have also finished life processes, which was a very big chapter. It needed six uh, different videos and six parts to complete that chapter. Now we are starting the physics part, and we will begin with the chapter Light, Reflection and Refraction. So let us start with the introduction, and let us try to keep it as straightforward and to the point as possible. First, we'll understand what is optics. Optics is the study of behavior and properties of light. So since we are studying everything about light, it falls under the topic optics. Optics is the study of behavior and properties of light. So how is it possible that we are able to see objects? Like what happens? Just we take the example of this man looking at the rose. How is he able to see an image of the rose? Light, sunlight falls on the rose. That light gets reflected into the eyes of the man, and an image is formed in the retina of the man, and he's able to see, okay, that's a rose. So that is how we as human beings are able to see objects in real life. The light from sunlight falls into the object and it gets reflected into our eyes. That is the way we are able to see an object. An object reflects light that falls on it. Eyes receive the reflected light and thus we see that object. We see through a transparent medium as light is transmitted through it. Now, the thing about light is that it travels in straight lines. Light always travels in straight lines. A small source of light will always cast a sharp shadow of an object that is opaque. So, light is usually shown as a ray of light. So, what we understand here is that optics is the study and behavior of properties of light, and how we are able to see objects. Light is getting reflected from it is falling on the object that we want to see. It is getting reflected from that object and we are able to see the object. Now let us move forward and let us see what is ahead in this chapter. Okay, fine. So now what is we have to discuss is light as particles. See, light is going, there is a barrier, and that barrier has stopped the movement of light and other particles have gone through. Light is a wave as a barrier and then as a wave. Okay, there is a very small opaque object on the path of light. It shows tendency to bend around it. This effect is called the diffraction. Here the straight line concept fails. Such phenomena can be explained by considering light as a wave. But wave theory often becomes inadequate for treatment of interaction of light with matter, and light often behaves like a stream of particles. And then there is always a quantum theory that says that light is neither a wave nor a particle. It reconciles the particle properties with the wave nature. Okay, let's move ahead and try to understand the reflection of light. See, this is a plane mirror and the boy is able to see his reflection into the mirror. So first we will try to understand the reflection of light, like the laws of reflection of light. What are the laws of reflection? How many laws are there? See, this is a plane mirror. There is an incident ray incident on the mirror, it gets reflected, and this is a normal, and this is angle of incidence and angle of reflection. So there are three laws of reflection of light. Generally we have just three laws of reflection of light. The first law of reflection says that the angle of incidence is equal to angle of reflection. This angle, the angle of incidence, is equal to the angle of reflection. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. This is the second law. Okay, so these laws are applicable to all types of reflecting surfaces, including spherical surfaces. A highly polished surface such as a mirror reflects most of the light falling on it, and what we observe is that image formed by a plane mirror is always virtual and erect. See, this is the image of the boy formed in a plane mirror. It is erect, it is straight, and it is virtual. It is not a real object image, it's a virtual image. The size of the image is equal to that of the object. The bigger the object, the bigger the image, same size. The image formed is as far behind the mirror as the object in front of it. See, the boy is at certain distance from the mirror, same is with the image, same distance behind the image. Okay. And further, the image is laterally inverted. What is the meaning of lateral inversion? Laterally inverted means, like in this recording, you can see me on top. This is also an example of lateral inversion. I have lifted my right hand, but in the video you can see that I have lifted the left hand. This is lateral inversion. I have lifted the left hand in reality, but you can see me lifting the right hand in the video. That is called a lateral inversion. So I hope this is clear. Let us move ahead. So basically what is important here? The laws of reflection of light, which are two. That says that the angle of incidence is equal to the angle of reflection. Okay, the first thing it says is angle of incidence is equal to angle of reflection. Secondly, the incident ray, the normal to the mirror, incident ray normal to the mirror, and the reflected ray, incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. Now, since we are clear with the laws of reflection of light and the properties of the image formed in a mirror, let's move ahead. Image formation by, let us try to understand the image formation by curved mirror. Consider the curved surface of a large shining spoon is a curved mirror. Okay, is a curved mirror. The image at its concave side is real, inverted, and diminished. Okay, real, inverted, and diminished. So this is the concave side, this is the convex side. So this is the concave side, this is the convex side. Okay, and real, inverted, and the image at its concave side is real, inverted, and diminished. If the spoon is moved away, image becomes smaller. Image at the convex side is virtual, erect, and diminished. If the spoon is moved away, image becomes smaller. The most commonly used type of curved mirror is the spherical mirror. Let's move ahead. Spherical mirrors. There are two types of spherical mirrors. One is concave, one is convex. So if we see a spoon, the part from which we eat is a concave, and convex is the other side. See, this is concave. Concave mirror is always curved inwards. Convex mirror is always curved outwards. Concave mirror, its reflecting surface is curved inwards, faces towards the center of the sphere. Concave mirror. Curved outwards, convex mirror, its reflecting surface is curved outwards. Okay, now let us see spherical mirrors. Now we will see some important terms, okay, related to the mirror. First we read about pole. What is a pole? See, this is the curved mirror. Pole is at the center. So it is the center of the reflecting surface. This is the reflecting surface. Center is the pole. It is the center of the reflecting surface of a spherical mirror. Reflecting surface is a part of sphere. Okay. Center of curvature. What is the center of curvature? At center. It is the center of sphere of which the spherical mirror is a part. It is not the part of mirror and lies outside the reflecting surface. Center of curvature for concave is this, convex is this. Okay. It lies in front of concave mirror and it lies behind the convex mirror. What is radius of curvature? Radius of curvature is the radius. Okay. Radius of curvature is the radius of the sphere of which the mirror forms the part. The distance PC is the radius of curvature. This is the radius of curvature. It can also be stated as the distance between the pole and the center of curvature. Principal axis. What is principal axis? Principal axis is the imaginary straight line passing through the pole and center of curvature of a spherical mirror. It is normal to the mirror at its pole. Let's move ahead. Try to understand what is a principal focus and focal length f. Okay. So this is the concave mirror. From infinity some rays are coming and hitting the concave mirror. So whenever rays of light are coming from infinity and it strikes the mirror. Okay. So whenever some rays of light are coming from infinity and it strikes the mirror, what happens is if the rays are coming from infinity, they all converge towards the focus. Direct the reflecting surface of a concave mirror towards the sun and direct the reflected ray on the paper. What will happen, guys? The paper will burn after some time. Move the paper to find bright sharp spot of light on it. Wait for a few minutes, paper burns and catches fire. This is because the light from the sun is converged at a point of paper as a bright spot. This point is the focus of a concave mirror. It produces heat and ignites the paper. Distance of this image from the position of the mirror is focal length of the mirror. Distance of the image formed from the position of the mirror is called the focal length of the mirror. This is the mirror, this is the focus. Okay. This distance PF is the focal length of the mirror. This can be represented as a ray diagram. Okay, this is for concave, this is for convex. Concave converges it to focus, convex diverges it, and from behind we extend it to the point where they all meet is the focus. Now let's move ahead. When several rays are parallel to the principal axis fall on a concave mirror, the reflected rays intersect at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. Okay, this is the concave mirror. This is the principal focus. See, all the rays are parallel, they are converging, and the focus, this is the point of the focus. Same with convex, they diverge and they meet behind the mirror at the focus point. So what do I conclude? I conclude that in a concave mirror, the focus is, or the focal length part is in front of the mirror. For a convex mirror, the focal length is behind the mirror. Okay, so this is the light, this is the focal length. Focal length is in front of the mirror in concave mirror. For convex mirror, the focal length is behind the mirror. Distance between the pole and principal focus of a spherical mirror is called the focal length. Distance between the pole and the focus, principal focus of a spherical mirror is called the focal length F. I hope it is clear till here, and I really hope it is clear, and I hope students are understanding the reflecting. Now there is another thing we have to understand, the relation between radius of curvature and the focal length. That also we'll understand. The reflecting surface of a spherical mirror is generally spherical and has a circular outline. Diameter of the reflecting surface is called its aperture. The distance mn, this is the aperture, this is the diameter of the reflecting surface, is called its aperture distance mn. We consider only spherical mirrors whose aperture is much smaller than its radius of curvature. For spherical mirrors of small apertures, radius of curvature is equal to twice the focal length. This is the focal length, twice of this. So the distance Cp from center of curvature till pole is the radius of curvature, and the focal length is here. This Pf, 2Pf is equal to Cp. The relationship that we derive is that the radius of curvature is equal to the twice that of the focal length. So principal focus lies midway between the pole and the center of curvature. So what we derive from here is that the radius of curvature is equal to 2 times of the focal length. Okay, now let's move ahead and try to understand the image formation by spherical mirrors. There is an activity. Find out approximately focal length of a concave mirror. Mark 3 parallel lines P, F and C on a table such that the distance between any 2 successive lines is equal to the focal length of mirror. Place a standard concave mirror over the line P such that its pole lies over the line. Keep a bright object at a position far beyond C. Place a paper screen and move it in front of mirror to obtain sharp image of the candle flame. Repeat the activity by placing the candle at different point, just beyond C, at C, between F and C, at F, and between P and F. Nature, position, size of image formed by concave mirror depends on the position of object in relation to the points P, F and C. Okay, so this is just an experiment, and we will see that how and what are the different types of images that are formed by putting the object at different positions by going through the ray diagrams of the concave mirror and the convex mirror. When we see the ray diagrams of concave and convex mirror, then only we will be able to understand where the image is formed and what is the nature of the image. That will be discussed in the next part of this video series. So stay tuned for this series. Thank you everyone.